Hello students, today we are in lecture number 9 of chapter 1, that is electrostatics. This is B S Pandey student. Now student, today in lecture number 9 we'll continue electric field and some important question on the basis of that electric field. In last lecture we have been finished student how to find the net electric field using superposition principle. Today another simple question we'll solve, and we'll start from this question and then we'll move to the concept of some elementary ideas. Okay, the question on the basis of line integral of charge. So the first question of today's student, we haven't studied the question student what should be the position where third charge can be placed to have the net force as 0. In similar way, today we are going to find out if you're having two charges, say 9 coulomb and minus 3 coulomb, microcoulomb. It is separated by a distance of 2 meters. If it is positive and this is negative, then the question is asking on line joining these two charges, at which point the net electric field will be 0. Okay student, to try to solve this question. First of all, student, if we'll place ourselves in between these two charges, at any point can we have net field is 0? Okay, try to find out this point. At this point, the direction of electric field due to this positive will be away and due to this negative will be towards. So the two electric field will be in same direction and it will never gives you the net field as 0. So of course we have to move out of these two charges. Now, as we have been discussed, we should move towards the smaller magnitude of charge. So we'll move. Again, I'm not taking you much time to explain why we are moving towards the smaller magnitude of charge. We have been discussed in question of force. At this point, suppose at P, which is at distance x, the net electric field will be 0. Due to this negative charge, the field will be in this direction, and due to this positive charge, it will be away in this direction, and E net will be 0, which is how much? It is E2 minus E1. Of course, if E1 equals to E2, then only we can have the net electric field as 0. Now, due to this negative charge, the field will be K, Q. Remember, we have to write only the magnitude, not the nature. 3 times 10 power minus 6 for the microcoulomb divided by R square. So from this negative charge, the origin point is x distance away is equals to the K, Q. It is 9 times 10 power minus 6 divided by the distance from this positive 9. It is 2 plus x. 2 plus x. Now cancel out this K. 3 3 is a 9. 3x square is equals to this will also cancel out 2 plus x square. Due to this data, this calculation becoming a little complex, but don't worry. 2 plus x, it is root 3 times x, so it is root 3 minus 1, x equals to 2. Root 3 minus 1 from which charge? from minus 3 microcoulomb. Okay, student, take another example for your classwork. I'm giving you the two charges. It is placed 3 microcoulomb minus 3 plus 3 microcoulomb, and it is 27 again plus, okay, minus 27 microcoulomb separated by the 2 meter. Okay, you have to find out the position at which the net electric field will be 0 due to the system of these two charges. Try to solve by yourself, student. Pause the video and try to solve this question. You have to find the position at which the net electric field due to these two charges on line joining these two charges will be how much? It is 0. Again, another question I'm giving you, students. Then after we'll solve few questions of NCRT, because we have to focus and we have to limit ourselves over the NCRT question. The few NCRT question I'll discuss in classroom program, and the number of questions are given already in my assignment that I discuss. So student, the question is, this is the positively charged rod of length L and charge which is uniformly distributed over the rod, it is Q. You have to find the net electric field at point P. This is a distance away from the rod, and length of the rod already it is given how much? It is L. So you have to find the electric field at point P from this rod. I hope that you can solve this question by yourself, but I'm giving you the hint so that those students were not able to understand this elemental question, because this is the very important. After this question we'll solve 3 to 4 questions again, okay, using a ring also that is given in NCRT even. Okay, so first we have to take elemental part of this rod of length DL, at which distance? At L distance from observation point. In length L the charge is Q. In length, unit length, the charge will be how much? Q by L. So in elementary length DL, the charge will be Q by L into DL. Directly we have been studied, we can write this as dq as lambda times dl also. And what is this lambda actually? So lambda is nothing but the Q by L, charge per unit length, is the linear charge density called lambda. So the electric field, since this is a positive rod, electric field in this direction, and small elemental part will give you, this is the elemental part of dl length of charge dq at this point P will give you electric field dE. So the dE can be written as kq dq, we have written small, by L square, kq by r square, that is the L square, it is dE. So the q, the value of dq, it is lambda dl over L square. Direction I cap, you can write if you are writing in vector form. So d integrate for E, k lambda, it is constant, I cap. Now students, sorry, the dl. Now integration, from where this rod is starting? Of course before A rod will not give electric field, because rod is starting even from this point, that is A. So the electric field will be 0 at point which is at A, and the maximum electric field, that is we have been discussed complete rod at which distance from P, it is A plus L, k lambda, and the minus 1 by L, integration of 1 by L square, integrating from A to A plus L, it is Newton per coulomb. You can find the answer. I don't think I need to find the complete Answer, student. I'm having a question from ncrt student. It is 13 or 14 example number would be there in electric field chapter. It is of ncrt. It is a positively and negatively charged plates. These are two plates. The upper plate is positively charged and the below one is negatively charged. Okay, it is negatively charged. The three charges are shown. The path of three charges are shown in ncrt. One, two, the very slight one, and the three, I think this one. The three charges 1, 2 and 3. 1, 2 and 3. This is the trajectory or the path of three charges. In question you have been asked to write the nature of charge 1, 2 and 3. The very simple question you can write, since one charge it is moving towards the positive plate, of course it would be negative, and this one is also moving towards the positive plate, so the negative, and this is moving towards the negative charge, so this will be the positive. Now the question, actually the next question of ncrt, it is given, that is interesting. What is that? If between these two plates, positive and negatively charged, in which electric field is maintained, of course from negative plate to positive plate, the electric field it is maintained is E. It is the strength of electric field. Okay, you have been asked, if a charge is fired in the space between these two plates, it moves and deviates from its path. This was the actual path. You have to find the deflection, this vertical deflection. What will be the vertical deflection? The charge, it is Q, mass, it is M, and it is projected with initial velocity ux. Okay, ux. You have to neglect the gravity. So in this question you have been asked to find the vertical deflection. How much this charge will deflect while leaving the plate. Of course you will ask, what should be the length, and what is the length of this plate, sir? Of course it is given, the length of the plate is L. Okay, so you have to find the vertical deflection. If you can solve this question, try to solve by yourself, student. Is there any force, students, along this x-axis? If this is the x-axis, answer is no. It means acceleration will be how much? 0, since mass cannot be 0. If acceleration is 0, then charge is moving with constant velocity, and constant velocity is what? It is ux. So the time this charge will take to leave the plate, it can be written as distance by speed ux. We are having time this charge will take to leave the plate. Very good. If you will be asked what is the nature of charge, of course you can say it is the positively charged particle. Now we have to find the deflection along y-axis. Is there any force along y-axis? Answer is yes. Along y-axis there is a force. And what is that force? Since this charge is placed in presence of electric field E, so the force will be Q times E, and this is the force, and due to this force the body is moving. and this force will be equals, since this force is responsible to accelerate the charged particle, so we can write here the QE is equals to m into a along which axis? Y axis. If it is QE is equals to ma, so a, that is the acceleration, can be written as the QE over m. So we are having acceleration as well, we have calculated the time, we have calculated the acceleration. Now the vertical deflection, we can write, since along the y-axis it is accelerating, so the displacement can be written as the s is equals to ut plus half at square, along which axis? Along y-axis. Okay, along y-axis. And along y-axis the displacement is how much? Y. Initial velocity along y-axis, it is 0, since the initial velocity it was taken along x-axis. So the initial velocity along y-axis will be how much? 0. So this term gone. Now half a, we are having QE by m, t square, how much? L by u square. So this is the vertical deflection y that you have to calculate. Now try to compare this question with the previous one. Okay, if you have been asked, this is the answer. I hope you got. If you are not understanding any of the point, kindly drop a comment in comment box, or you can ask in group. Now student, if you have been asked that find the charge by mass ratio, which one having the charge by mass ratio, that is the specific charge by mass ratio greater, 1, 2, 3, charge by mass ratio Q by M. Okay, for which charge by mass ratio is greater, then how you will solve? So student, I am solving this question because this type of question has been asked in examination, charge by mass. So in this question, which one having the charge by mass is greater? So the charge by mass, from this equation you can write, a student, from this equation you can write the charge by mass as y is equals to, okay, y is equals to half QE L square by M U square, it is along x-axis, and the charge by mass Q by M can be written, this is the Q by M can be written 2 y u x square divided by E L square. Okay, so this is the charge by mass ratio. Which one having the greater value, 1, 2 or 3? This was the question actually. Now try to find out the constants value. Here 2 is constant, u is constant for all the charges. If all the charges were projected with the same velocity, it is constant. Electric field is constant for all the particle, uniform electric field, and L is constant. So all the quantities are constant. So the charge by mass ratio is directly proportional to which one? It is y. Now it is obvious the value of y will give the charge by mass ratio. Okay, the charge will deflect much, will have the larger charge by mass ratio, and it is clear by the figure. You can see the third one having the greater deflection with y, it is the much smaller, and this is the moderate. So the charge by mass ratio Q by M of 3 will be larger than Q by M of 1, and then Q by M of 2. So such type of question you may be asked to solve charge by mass ratio. Now you are having another question in your NCRT, and I hope you can solve if you understand properly. Now students, another question, the very important question, and such type of question will be asked in board as well, competition. Okay, could you find the electric field? Could you find the electric field due to charged ring or semicircular ring. This is the semicircular ring. Could you find? At the center of the ring, radius of the ring, it is r. For the stereo charge ring, you have to find electric field at this point O, at the center of the ring. How you will solve it, student? So listen carefully. Those students can solve, try to solve by yourself. Otherwise, look at here carefully how you have to solve this question. Take elemental part. This is the elementary section. Take elemental part. Radius. I'm rubbing over here is confusing. Now, dl will be the length you have been cut out, and it is at an angle, suppose theta. If this is the positive charge, okay, this is the positive charge, over here, so electric field will be in this direction. The concept behind two elemental section is only and only that a student can have the argument. So why we are taking the two elementary section? As I told you earlier, the benefit of taking two elemental section is to remove or is to simplify our calculation, because this theta will give you the theta over here and the theta over here. This is the elemental part. It will have the two component, dE cos theta, and this is also will give you the dE cos theta, okay, and dE sin theta, and the same dE sin theta. Now this two will be cancelled out. This is the reason behind we took the two elemental section. Now the net electric field from this figure I am writing here, the net electric field, it is E net is nothing but the twice dE cos theta. Okay, one student can have argument, why this is 2, sir? Because this all other elemental section, we can have the number of elemental section and we can integrate, and we should integrate by removing this 2. Of course, students, you can integrate by removing this 2, because there is no only 2 elemental section, there are number of elemental section. Why we are not writing a 3, sir, 4, sir? For simplicity and symmetricity, we are writing over here 2, and we are integrating for the half part of the ring, okay, because this elemental section will give you the electric field due to this half part, and this elemental section will give you the electric field due to this half part. Okay, so there's nothing very much fruitful for behind the argument why we are taking here the 2, student. Now we'll integrate. First we should put the values, okay, and direction, of course, it will be in this direction, x-axis I cap, you can write. So 2 dE, to write the dE, we have to find the charge, the total length of the ring. What is pi r? In pi r, the total charge is q. In unit length, the charge will be q by pi r. Okay, so in dl length, charge is q by pi r times dl. It is nothing but the dq. How much? Q by pi r times dl, and this is the charge. Now you will put this value over here. E net, it is 2 kq by r square. This is the observation length. It is nothing but the radius. R square, it is kq by r square, 2 to dE. Now cos theta. Cos theta. Since this cos theta is constant, you know, cos theta will not change. If you are taking this dl little bit larger. Okay, this theta is going to be changed. Very good. So you need to just convert this. First put the value of dq. It is 2k dq. It is q by pi r into dl over r square cos theta. Okay, now 2k q over pi rq dl cos theta. Here two variables we are having. Okay, dl and cos theta, and we cannot integrate the equation having the two variables. So try to convert this equation in one variable. How? Here you are having the elemental section as dl at distance r, and this is the elemental angle d theta. So you can write this theta is equals to dl by r, or dl is equals to r d theta. Now you will put this value of dl over here, and one variable will gone. It will comes in r and theta. Already we are having here the one variable theta 1, and this r is constant. So now our work will be easier if we have integration in one variable. So the E net we can write 2kq by pi rq and dl r d theta, that is r cos theta d theta. All are constant. You have to integrate only this one. So the 2kq by pi r square, I hope you understand. Cos theta will be, integration of cos theta is sin theta minus sin theta. It is sin theta. Okay, so this angle theta is increasing from here. Okay, from 0 to, for the half one, it is from 0 to 90 pi by 2, and this will also integrate from 0 to pi by 2. Since we have taken already here the 2, we do not integrate from here to here. If you will cancel out this 2, then you will integrate minus pi by 2 to plus pi by 2, or the from angle you consider 0 to this one. Okay, so this is your reference, minus pi by 2 to plus pi by 2. Now you can find the answer. How much it is? 2kq by pi r square and sine pi by 2 minus sine 0, upper limit minus lower limit, kq by pi r square 1 minus 0, overall 2kq by pi r square Newton per coulomb. This is the answer. You can convert this answer in lambda also. You can convert this answer in terms of lambda. Lambda is what? Lambda is the charge per unit length. Okay, students. So we have taken this lecture so far. I'm giving you a home assignment, a part of the assignment from my paper. This is your home assignment, which is from ncrt. Little bit. You have to find the electric field at point P. Okay, due to this ring. What is the orientation of ring? Student, try to understand how this orientation. Ring is not in this way. You have to find the electric field. Actually, ring is placed in this way. Okay, you are getting this view, and from center at the point. Okay, from center, this is the position. Okay, I hope you are understanding. From center at a distance x, you have to find electric field at point P. All the things are given. Radius is r, charge is plus q distributed over the length of the ring, you have to find the electric field at point P. Okay, students, so try to solve this question. This is all about today's lecture, students. Thank you.